Hey, guess what, folks? It's time for the Nerd Log. It is Thursday at noon, which is the usual time that we do the Nerd Log. I also discovered today that not all of my state of Oregon is on Pacific time. That there's not even one county, but part of one county is on Mountain Time because they love Idaho so much, which is on Mountain Time. Anyway, that's the new information. It's the Nerd Log. We have one guest to start with who I'm very excited about. Bassam, introduce yourself. Normally I say introduce yourself, tell the people what you do for New Relic, but you are not from New Relic. You are from Gigamon. Say hi to the people.
Hey, everyone. I'm Bassam. I look after product marketing, technical marketing, engineering here at Gigamon. Just a quick background on myself, Nika. I went to Boston University, Carnegie Mellon, started my career off in programming for an investment company in Boston, came out to California for a holiday, and almost as a joke, I hate to say this, I got an interview because somebody knew somebody at Oracle, interviewed, and I got the job. So from late 90s onwards, I've been here in the Bay Area. So after Oracle, I've been doing startups and on the security side and so on. And am at Gigamon for the past 3 years.
So that means you've been in California since then. You left the delightful delights of trying to walk across the street in Boston for California.
Yeah, it was really interesting move because we left in middle of winter, one of the worst winters Boston's ever had. So it's kind of a no-brainer from that perspective. And Oracle was an interesting place too, now that we're talking about this. So I really didn't think I wanted the job. Things were going, very well for me at work, and we had this house in Boston, and we weren't gonna. And just to kind of, a friend of mine had moved here from Boston. She wanted my resume, and I was like, no. She's like, yeah, give it to me. Just to kind of quiet her, give me a resume. So I went to Oracle, interviewed. I was a little cranky. I, lose a day of the vacation, a few days that you get, and bring a suit at that time and everything.
Yeah.
So I was really cranky. I was really like, that's not how you do business. That's not how you sell your product. And I was really challenging them. And if I wanted that job, I really wouldn't have been that direct and that route.
Yeah.
I came back. I was telling everybody, just forget it really badly. Next thing I know, I get a handwritten signature offer letter from Larry Ellison saying, "We want to hire you. We like you." I was like, what? But it was a really fun move. So I was in IT and then moved into onto the dark side. I was in the vendor side of
Yeah, I think one of the things about the kind of work that we do, where we talk to people about how the system works, or we try to explain how it's working in the marketing side, and it is funny that I genuinely think you cannot do this as well if you have not had some exposure, like doing some product development. Yeah. It's just harder to understand and explain, and it just makes the job too difficult.
There's only one way to learn what happens when a pager goes off at 2:30 in the morning and you're so disoriented and something breaks at work. That doesn't really happen as much on the role that I've been in since Silicon Valley.
Yeah.
IT, that was a common thing. And 2:30 versus 4 o'clock at 4 a.m. when I was in pager duty.
Yeah.
The difference, this application is running now, and this was the big print job that something happened, and you kind of know, and you get this twitch in your body every time you hear that vibrate or beep beep beep.
Yeah, it's so funny because of course that is what we're talking about, and I because I talk to people so much about New Relic now because I have a weekly Twitch show, I feel like, oh my god, people are sick of hearing this example of the 2 a.m. page or that kind of thing, but that is also that is the reality, that the better that you can understand an outage or a problem and be able to say, like, when you get that page, like we've all felt that sense of like, I do not know what is going on. And like, for me, the classic is maybe not 2 a.m., maybe the afternoon, you're in the office, but then you're like, oh wait, maybe we just have like local caching of the service. So now I'm turning off the Wi-Fi on my phone. Now I'm like VPNing to somewhere else in the world to try and even see the problem, right? Before we're even getting to logs and trying to figure out what's going on. And it's just an active part of everyone's operation. And very often, I think we take that stuff internally. We think, oh, our org has so much tech debt or such bad practices. That's why this was so hard for me. When the reality is, this is just what happens. And it is really rough on everybody. And so you have to figure out, like, how can you build the tools and build the systems that improve that.
That's exactly right. And it's knowing the pain and having gone through a lot of and we're talking about the bad stuff, but even the good stuff, being able to bring in a cool technology on the flip side of, getting woken up at 2 a.m. Here's how I made a huge contribution. Here's how I built my career in this IT organization with this new capability that's been brought in. And that really is what gives me the most joy in being on this side of technology, is that we tend to have a lot of cutting edge, a lot of new capabilities. And it's not meant to be, actually a lot of vendors will provide, flashy lights and buzzing everywhere kind of a software, or hardware for that matter. But what really matters and what gets me out of bed and very excited is the impact that we have on a lot of people being able to do their jobs, and the impact they have in being able to have satisfied customers, whether it's their users and so on.
Yeah, and in fact, I think that's a big difference with how we do cloud enablement. Is sometimes it's like, hey, we're going to sort of convince the boss on the golf course that we're going to launch them into the 32nd century and do all this amazing stuff, and then that has its value and that's a way to make money, and I get it. But then there's also the side of just like, hey, I'm making life just a little bit easier for people who have to maintain this stuff every day and don't have the level of control that we would like. And so how can we tool up to that point? So let's talk about Gigamon, which I first knew from publishing a good deal of stuff about cloud migration and people kind of stuck in that state. But yeah, let's introduce that. Let's talk about it.
Sure. Let me give sort of a 20-second history of Gigamon. So we started in the mid 2000s. Gigamon is, back then, gigabit monitoring, gigabit Ethernet was a big deal. It was a new technology. It was starting to become prominent. And so that's where the name came from. And there were these three guys, Ted, Patrick, and King. Very, very Silicon Valley. It was down here in the Bay Area where I am. Very Silicon Valley lunch. They were from three different companies, really smart people. And they were talking about the same problem, and they're all in networking. They're talking about the same problem that they were having with these customers. And they literally took a napkin, I'm not making this stuff up, and they drew this diagram of the problem that they were having. And that was the first. I wish somebody had saved that napkin. That would have been stuck that in our front lobby. That's how we started. So basically, the notion here, Nika, is that there's a lot of data in motion, a lot of packets and network traffic and communications and good communications, bad communications going on in any organization, whether it's on premises, in a data center, with the good old world of people coming to the office, or bad old world, whatever that was, to private clouds and traffic between virtual machines within a VMware environment, let's say, all the way up to public cloud and multi-cloud and so on. So if you provide a tool that's responsible for analyzing the traffic, if you provide a tool that's responsible for monitoring traffic and the things that they get out of the traffic, whether security use cases, application use cases, performance use cases, and so on, they need access. These tools need access to that data in motion, to all data in motion without any blind spots, because if you have blind spots, it's a security risk and so on. So what we do, what I should say is, without us, every tool and typical organization, large organization, and a data center might have dozens of different kinds of tools, from firewalls to IDSs to DL, data loss prevention, and so on. And each tool has to go out and do this really hard work of plugging into every part of the network, every spine and leaf architecture, every branch office and closets and all of that. So we do that one time, and we've plugged in everywhere, and there's a number of more efficient ways that we can do that. And then on the tool side, you have to plug it only into one place, which is kind of a neat concept way back when, because back then the internet was growing quite rapidly, and the tool stack was growing quite rapidly, and it was really hard to keep up with the changing network.
And of course now everybody lives there because they live in microservice world, where they know week to week things might not be what they expect. But yeah, that really was the start of just, when they say, oh, the architecture exists on this whiteboard, it's this whiteboard that gets passed around or something, that for a long time, up until the mid-2000s, which I sadly remember in the tech sector, that whiteboard really could be the map. It could have the IP addresses written down or IP ranges written down. And this really is all of our services, right? Where then it became, okay, abstractly, the whiteboard gives you some idea. Oh, there's this, this set of servers over here, or this is a load balancer, or what have you. Now it's like nobody has track of that, right? And you could never map any modern architecture. But yeah, something we see for New Relic as well is very often we'll come to importing some data, and it's like, well, isn't this data available over here in this other tool, right? Classically in public cloud, it's like it's available from AWS or Azure, and
that's right.
Maybe we're adding to it, but initially there's just, hey, the data that's already over there, we want it here too. We want it in one place, because the sort of trying to integrate that information asks too much. But anyway, go ahead. Let's the Gigamon story. Back to the Gigamon.
Yeah. So as you just mentioned, so we went from the classic on-premises to private cloud, doing the same function of pulling all the data into one place. And by the way, when you aggregate and pull all the data into one place, there's some magic that you can do to the data. Things like basic functionality like deduplication. Typical organization that we get rolled out to, we see about 54% of the data being duplicate packets. And just simply by deduplicating the packets, and this is the kind of an artifact of every real world network deployment. You don't want any duplicates, but it just happens. So just the act of deduplication will double the capacity of your tools, because if you didn't have Gigamon, the tools would be seeing double the traffic. And by deduplication, we're sending all the packets they need and none of the duplicates. And duplicates packets add zero value from a security perspective. They add zero value from a monitoring perspective. It's just noise. So that's one function. There's about 18 other things that we do. Decryption and those types of things.
Oh, interesting. Yeah. So now let's talk about how this sort of connects over to New Relic. So, we have talked about networking sort of as a theme for about a month and a half here. And the big thing is this actually starts for New Relic about a year ago when we say, hey, we want to have this open source strategy. And I've told this canard before, so sorry, longtime viewers, if you're tired of hearing this, but it really stuck with me. When we first talked about network performance monitoring with Kentic, I thought that we were talking about sort of a classic integration thing, where it was like dozens of engineers on both sides. We did a big API integration, and you have to talk to 2 enterprise sales representatives to be able to get this set up, and so on and so forth. And you're going to have this sort of odd interface where one thing is shoved into the other. The reality was, though, that we did that integration happened as just a weekend project, where there were just way better ways now for data to get into New Relic and be like a first-class citizen within the New Relic system. So we're super excited because we get to have these conversations about really neat, deep data from really interesting perspectives showing up within the New Relic interface. So sort of when did you first become aware of this or start taking a look at it?
So that's a great question. It's like kind of multiple phases. I guess the first phase was is just having this capability in the cloud, which we've been doing. Gigamon's been doing for about 3 years now. We've got over 1,000 large enterprises using us in the same kind of the good old world of packet brokering in the cloud, because there's still need for network traffic in the cloud. Actually, let me double underline that. What we've seen, or what the world's seen, is when you move a workload to the cloud, as you're maturing in the cloud, or when you first get to the cloud, you're like, you know what? I don't need to worry about networking, because AWS, Azure, whoever's going to take care of that for me, I don't need to look at it. And my SLAs are guaranteeing the performance, guaranteeing uptime, and so on.
Yeah, we don't configure routers anymore within their stack. So clearly, we can fire the networking people, right?
Exactly. However, when something goes wrong, or particularly from security use cases, there's a lot of value that you get from evaluating the network. And it's very obvious to most of the people on this call. But it's amazing how much we hear the story like fresh from customers. When we talk to customers, we were kind of ignoring that. And this phrase that I use is, network data has become the baby with the bathwater, which, by the way, I hate saying. I grew up abroad, and when I first heard them, I'm like, what a terrible saying.
Yeah.
So mean. It really is the case where now we're at a mode where people are looking at the data and saying, hey, there's a lot of really rich data in there. So we have MELT, so metrics, events, logs, and traces.
Mm-hmm.
And what we allow our customers to do is add the network intelligence part to that. So network intelligence is composed of packets, flow records, and metadata. Metadata is really where it gets interesting. So we've launched this in March of this year. So we had actually spoken with New Relic October of last year, roughly. And we kind of talked about what we were doing. They're like, yeah, come back to us when it's real. So when we did the, we call it the Hawk launch in March, that's when we did some joint work, and New Relic was one of our flagship partners where we launched this. And then the most recent work that we did with New Relic was the instant observability launch that you guys did about a month ago now, a month and a half ago now.
Yeah.
And that was a lot of fun. I mean, I am amazed with what you guys have done with the quick starts, with how easy it is to get everything up and running and be able to see an integration live as fast.
Yeah, for those of us playing along from home, instant observability is basically just a concept and sort of how we're going to give people an interface to add new data into their New Relic dashboard. And so it's something like a nice interface for starting quickly and adding stuff. I'll drop a link to it here. And the neatest thing about it to me, I think we have a pretty smooth way to get your NPM, your Node.js server data into New Relic. But as we work with partners, we're able to say we've always been able to, or we're now able to integrate this data, but let us show you how, again, that first class citizen thing where we're able to show it sort of towards the top. That's always pretty neat.
Yeah, and it's been you talk about not an army of developers. We had one guy on our side.
Perfect.
And a little bit of guidance from your side, do this, don't do that kind of a thing, and boom, it's in there, it's up and running, and I can actually walk people through it in a little bit later.
Yeah, so let's maybe take a look at some stuff. Let's look at some data, or let's look at a little bit of an explanation. Let me, when you're ready, I'll hit the button on the screen share.
Yeah, so while you're doing that, let me just kind of jump a little bit into talk about use case. So we pull out a lot of data from the network traffic. So rather than sending packets, we're pulling out metadata, and there are about 5,000 different metadata attributes that we're pulling out. Now that's encyclopedia, dictionary, what the heck am I supposed to do with this? So we have a number of guidances that we provide around that. So we did something really interesting that I haven't done to this level ever before in the 20 plus years I've been in Silicon Valley, which is we, through a third-party agency, we interviewed 36 different cloud IT high-level people. 18 of them were C and SVP level, and 18 of them were director level. And 100% of them, all 36 of them, we said, what's your challenge? The number one thing that came up was security, cloud security. And everybody had different, talked about ransomware, they talked about cryptocurrency came up a lot. They feel like their organization is, target, and there's many, many points of entry. The risk exposure, the surface of attack has gone up. So there's a lot of concerns that they have. So what I'll walk you guys through is off the different use cases. We kind of zoomed in the beginning of our work together around security use cases.
Yeah, this is another thing where I think initially a lot of us thought, as we're moving to a public cloud, as we're moving to AWS or Azure, it's like, well, now security is less of a concern because there are all these security concerns that are completely handled within our contract. Of course, like configuration vulnerabilities and code injection are things that AWS or whoever doesn't care about at all, quite explicitly. As I always say, the first thing they make you learn in certification is the separation of concerns, right? And hey, you've left this port open, you've left this VM open and vulnerable, is explicitly like, no, AWS will not warn you about that. That is their whole deal. That is your concern, because they don't want to be, scanning your devices or analyzing your network traffic. It's not the business they're in. So, yeah, and in fact, I have somebody I follow who I actually quite love and just sort of pokes around and tries to set up things in AWS without looking at much documentation or training, and every single time gets hacked. And every single time, because there's a YouTube video of them setting something up, they end up with like, yep, got another cryptocurrency miner set up on my EC2 instances again. Repeatedly having to wipe all their resources out and start over because, it is extremely active, the threats that you can get.
And top of mind concern, and so we were kind of, cost came in at number 2, not quite a distant number 2, but everything else was pretty far off. Before I jump into the product and the UI itself, I'm just kind of set the stage a little bit if I can, Nika. So what we have here is it's typical customer infrastructure, typical IT infrastructure. We've got infrastructure, we've got technologies, and each technology has a different way of pulling out data from either raw packets or information about the packets. And there's all kinds of challenges around that as well. So what we provide is simply, and the other thing that you mentioned is, as soon as you draw something on a whiteboard, you can have an entire diagram. Nowadays, as soon as you've drawn the last line, it's already out of date, and it's always evolving. The environment's always changing. As a result, it's difficult to do security performance troubleshooting. But more specifically, it really is at this level. So some of the things we've heard from our customer is, you know what? There are native tools like VPC mirroring, packet mirroring in GCP and others that I can use to extract the traffic out, but they're not designed to have a set of tools where I can do one-to-many targets. So there's some challenges around scaling up as I go from 1 VM to 50 VM and scaling back down again. So Gigamon this is a challenge, and we kind of help with all of these. The second one is container traffic. Getting container traffic out over CNI or however you do it is still quite a bit of challenge. And by the way, I'm talking about packets now, but I'll talk about the metadata that we're extracting once the traffic is pulled out. Discovering unmanaged hosts, and it's the unknown unknowns. It's the IoT device that's connecting that does not have any kind of agent. It's the BYO. It's the printer. It's the heart rate monitor. It's all of those devices. Hard to track.
Yeah, no, these first three really stood out to me when you showed this to me the first time. And I apologize, the text a little small, folks, but watch the high-res version on the replay as well. But send traffic to many tools and auto scale, right? Inspect container traffic and discover unmanaged hosts. These are all things that are just really active for anybody working in these operations areas, right? And I don't think anybody's going to say, no matter how well resourced and how knowledgeable they are, that like, oh yeah, this isn't a concern at all. Right, like what traffic is passing to and from and between containers is like that's tough stuff, right? This is takes work to stay abreast of. Sorry, go ahead.
Yeah, that's exactly right. The east-west, crypto lateral movement. What every cryptocurrency mining software tries to do, the hidden ones, is they look for through using tools like Mimikatz and others. They do memory scraping. They try to get on other machines, and those are all happening between container to container.
Yeah.
The fourth one here is detect shadow IT, torrent, and cryptocurrency mining. We talked about this quite a bit.
Yeah.
Thing, Nika, that we've heard this over and over, and the reason crypto mining is such a popular attacker bad guy thing out there is because the road from intent to cashing out and profit and all the steps in between is so much shorter for the attacker.
Yeah, it's an afternoon instead of weeks of prep and trying to get someone to actually pay you and all this nonsense.
And having mules to go in the middle and paying the middleman. There's no middleman here, middle person here. It's just the insert this and bing ting ting.
Yeah, I mean, I think the basic reason that right now you see security threats as a very active thing, right, is that two big motivations, blackmail or hostage taking through encryption and cryptocurrency mining, they make good money, right? And it's happened many, many times. And cryptocurrency is the path in both cases. But, when there's profit to be had, right? When there's damage to be done and profit to be had from causing the damage, like we exist in an era where this stuff is pretty active.
Yeah. Yeah, other than these state actors and everybody else, and state actors limited number, very, very dangerous for limited number. Everybody else is in for the money, and this is the short of it. The last couple of points here: meet network-related compliance and SLOs. So there are a lot of compliance like SOC 2, Type 2, and other compliances that require that you inspect the data. And last one here is troubleshooting in a hybrid cloud applications. When someone says, "Hey, my app's running slow," we provide some network-level visibility and network-level metadata, and I'll show you some of that later on. That allows for much, much faster troubleshooting, mean time to innocence and all of that. Let me do one more part of the story here. This is where a visibility analytics fabric comes in. This technology used to be called Network Packet Broker many years ago. And the four general functions is to access all of the data one time, is to broker that traffic or the metadata over to the tools on the right-hand side, do any kind of transformation that's needed, whether it's decryption, packet slicing. You can mask over if there's PII-related data, you can mask over Bassam's medical record and credit card information, whatever you'd like to do before sending that over because of obvious reasons. And last one is analysis. That's the key part here, and that's what I'll touch on and show you guys next, which is really performing deep packet inspection on the traffic itself and then exporting the data out to New Relic to be able to do some analysis and presentation. By the way, one thing I forgot to mention, Nika, is that all these things, that what we do, we're sort of the 3M of the world. We don't make the trains make it run better. So we have no UI that analyzes the data for you. We don't have any, we don't provide any kind of analytics, visualization of the data or anything. We rely on partners.
Okay.
And there's one exception, that threat insight you see on the top right. That's a very specific network detection response technology that we acquired. But for everything else, for all use cases, the cool thing here, that from our perspective, and this is what we're hearing from a lot of our customers since the incident observability launch, is that we're bringing a lot of security use cases over to New Relic. Now, are people going to be saying, okay, great, I've got New Relic, I'm all secure and everything? No. What this is basically is that we provide together an additional layer of security in a defense in depth. So yes, you've got the firewalls and extra firewalls, and you've got DLPs and all of these. However, it's always good to have, and it's always very desirable and very effective to have this webbing that kind of overlap each other, different technologies of security.
Yeah, and that's a sort of a pretty consistent concept, right? Anytime someone says, well, I have this one thing, it's going to really solve security completely, very often that's usually related to network monitoring, right? You should be quite suspicious, right? Because the fact is that each attack is going to reveal itself in a new way.
That's right. So with that, let me see if I can move this window around and jump into the screen. So let me show you how we're integrated. This is the last slide. So we've got
good. Yeah, I mean, no worries.
Good.
Anything that actually has like how the architecture actually works, I'm like, this is what I like.
Excellent. So on the left-hand side, you've got the infrastructure, the ugly beast that I was drawing earlier. It's this complex beast that's constantly changing. So there are devices and hosts and so on. And there's sort of a managed universe and unmanaged universe of hosts. And typically, metrics, events, logs, and traces is what comes in New Relic, and then you get the dashboard and so on. The way we fit in is we have either our virtual tap, or we can rely on the native tapping mechanisms, whether it's packet mirroring, BBC packet mirroring, or Google Cloud mirroring as well. And Azure doesn't really have anything, so they recommend using something like a product like ours. But you get that, we get the traffic out, and it doesn't matter where it's coming from. It could be from VM, it could be coming out from a container. The only thing we don't do yet is serverless. That's a whole other story.
Yeah, we'll tell the story in a minute, but definitely you can't hit the network layer right between serverless entities, so that makes some sense. Anyway, go ahead.
All right, so all the data comes out. At that point, we do that deep packet inspection. So with AMI, it's our internal geek speak internally. That's application metadata intelligence. And Ceph is, I forget what that stands for, but it's one of the standard formats along with IPFix. And we send it over, and we send that up to around 5,000 different metadata attributes. Obviously, you don't want to do 5,000 because the CPU consumption on our V series on the left-hand side is going to go through the roof. It's going to cost a ton of money. But you select a subset of the attributes, you send it over, and it comes into dashboards, whether it's Gigamon alone, standalone dashboards, or more likely integrated dashboards. So you've got the Relic data in half of the dashboards and reports, and then you've got Gigamon provided agentless data coming to the part.
Yeah, and this agentless is a big concept, right? Because maybe we're about to say this, but a massive thing when we're thinking about security is when you're thinking about something like your printer or your load balancer or something else that it is impossible to install an agent on, right? So saying, we want to monitor everything, you have to figure out how to monitor these things that might be like my lamp, right? Which is accessing the web, has memory, has a complete like FPGA probably running on it. But yet obviously cannot have a monitoring agent installed. Anyway, yeah.
Exactly. So what I'm going to show you is this middle box here, what the UI looks like. What we're going to do is pick some attributes, some metadata, some subset of the 5,000. We're going to be sending it over to New Relic, and we're going to be looking at the New Relic dashboard. Before I get into that, I should probably, actually, you know what? I'll do that later. I was going to jump into New Relic Quickstart itself, but maybe I'll get there later. So coming in, I believe it's buffered. So this is our UI. And unfortunately, so the demo diva is not with me today, and the data is very, very not looking pretty right now.
This is always the thing with live data, right? We always want things to be broken enough that we see some anomalous data, but not so broken that the dashboard's not working.
That's right. Or it's like really basic. The good news is the product itself is working. I'll show you what that's doing. It's just the incoming data is some challenges. So it's I hate this term, but we use this at Gigamon, single pane of glass. But it's one sort of a UI, one platform that collects data from all the different platforms. And by the way, when I say collects it all, it doesn't mean that you're centralized in one place and you're doing a lot of egress expenses and so on. It could be data could be kept and is always kept in our customers in the different areas that they have. And if it's on premises, it usually is centralized because that's where the tools are. So anyway, so the way the system works basically is let me just come over here, go into virtual. I'll come over here and I'll just pick a workload. I'll tell you what I'm doing here in just a second. So this is sort of our canvas, and our customers are able to do this. And developers may not care about this because it's something that'll happen on the operations side. But basically, pass all is the collection of all of the data, and then you grab that and put that down on the right-hand side. We put any kind of destinations. It could be a tool port on the physical side. It could be a tunnel. It could be anything that happens. At that point, you simply grab the traffic and drag and drop the traffic and bring it over to the right. Except what most people want to do is put some other function in the middle. So in this case, I just put in deduplication. You can say, you know what, I want to mask out some of the data in some cases. So
oh wow.
So yeah. I want to mask. Oops, I gotta do this right. I want to mask before I send this to tool one, but tool one. But for the ntop ng, I am just going to send this as is. Okay, I'm doing this on my laptop. It's a little bit further away from me. Not like cool. So that's simply how it works, right? So we're sending the data over. But let me jump into application intelligence, and I mentioned that you get to pick whatever framework is and so on. So this is the application intelligence interface. Again, as I mentioned, the data is not looking very pretty today, but I can get the point across. So what happens is through deep packet inspection, there are about 3,000 different applications that we could identify. So these are the applications that are running in this organization. There's 188 different applications in this sample data that we have right now.
Okay, we have to pause the show to talk about the fact that somebody's still using Flickr just out there, right? Flickr doesn't exist anymore, right? Have I turned 1 million years old? It's gone, right? I mean, I understand demo data, I get it, right? It's just funny that it shows up, right?
Can I share a quick sidebar here? When we launched this, so we're in the large organizations. We're in 10 out of 10 federal agencies. We were in this highly secure federal agency. I wasn't there. Our sales engineer was there. And said, hey, let me turn on this feature and see how it looks. So they turned this on our boxes. And they're like, wow, this is really cool. I can see the applications. And wait, this is wrong because I've got BitTorrent running in we have a secure environment. This is not right. And so our sales engineer looked into it and said, no, it looks right. And the person looked into it and is like, oh my God. So he goes, come with me. So he grabbed our sales engineer's laptop and ran over into their SOC and said, hey guys, we've got BitTorrent running on our network. And the response back was NFW spelled out fully. That's not possible. And they looked into it, and sure enough, they saw somehow somebody was running BitTorrent, some level of BitTorrent traffic in that network.
Yeah,
it happens. Flickr, you're right, but
don't install BitTorrent on your work laptop, y'all. Just don't. Why are you doing that? Go and buy a computer with all the money you're not spending on old DVDs of Seinfeld. Please do it. Just a little personal note. But yeah, okay, so we're seeing multiple applications running on the network. We're able to match patterns of packet information with an application.
That's right. So that's what's happening here. And let me just get very quickly into picking out. Actually, maybe I'll skip over that right now, just from a timing perspective. So basically, we provide all the different protocols. And we show the traffic that's. I can move this thing down. No, it's still loading at like 5,000 attributes right now. But basically, you can pick which attributes you want to bring over. So let's jump into New Relic. And so here, the way to get to us is you simply go to the quick starts, and you will see Gigamon Hawk by Gigamon right there. And we've got all the documentation and stuff, and I can pull that up in a minute as well. But let me just jump into the dashboard side. Oh, rats. You know what? I'm going to switch over to Safari. I hate to do this, but that's where my...
No worries. I'm just going to hop to the 2UP just so people don't have to necessarily watch us type email addresses and passwords, just in case we generate some unexpected emails. While that's happening, I'll tell you a little funny story. Wait, I already did that one last week, so I'm not going to do that. Oh, I do have a good one, folks. While we're getting this set up, oh, you be ready to go? I'll tell it later.
Go ahead.
It's a good one, but unrelated. Okay. Oh, this looks good. Can we get a bump or two of zoom in and enhance? Can we get some browser zoom here? Yes. There we go. Big enough to show up on stream. Not so big that, of course, we switched to like a mobile layout. I think we got it.
Perfect. Okay. So I mentioned security use cases, and let me walk you guys through some security use cases. This is from the data coming in that we have done deep packet inspection, extracted metadata, sent it over JSON over to New Relic, and packaged that as a quick start for you guys. So some use cases here that our customers have told us, and they're actually using this quite a bit. First one is SSL version. So based on network traffic, whether it's an agent-based or it's an old security camera that's running somewhere, assuming that they do some level of encryption, what version they're running. This is really useful for customers that want to take out an SSL 1.0, 1.1, 1.2. We still see some really old equipment, really old applications still running that. And same thing with ciphers on how, taking out old ciphers and such. And the other big use case here is also, we look at the expiration date or time to live on the certificates. That's a bear of a problem to solve, to know.
Yes.
What's
oh my God. Yeah. I'm not an operations person. I'm more of a code developer, but yeah, having realized that, like, I believe at one point I had to try and like grep to try and find, run a regex to try and find when our expiration dates were and what was expiring. Anyway, go ahead. But yeah, that's a real one.
And when a certificate expires, guess what? Your application that you built ain't going to run. That server's not going to run anymore.
Yeah. What was the last major outage caused by that? Something big, I think, in the last 12 months for sure.
Yes.
But yeah, it just does happen.
Yeah. So again, the data here is a little sparse, but basically, and we need to make it look prettier, but and such. By the way, we pulled this thing together with, as I mentioned, one developer at the launch about a month ago, and so it's a really brand new, cutting edge material that you're seeing here. By the way, I also mentioned that there's nobody else that allows this level of visibility, and I'm not saying this is an advertisement. I'm saying this as being in IT as a cutting edge, getting a step ahead, or at least one step closer to the adversaries, in having an extra layer of defense to know, and I'll get into some of those defense types of things and just below this.
Yeah, I mean, something very real about this. I guess we didn't get a chance to say this yet, but the fact is, right, the massive SolarWinds attack. When you talk about how would you prevent such an attack, it's tough, right? A supply chain attack is a tough one, but how was it detected? Right, it was detected through network analysis, and in fact. No shame at all, but two people did notice this and end up not reporting it up to SolarWinds because they weren't sure that that's what they were seeing or whatever. They had other stuff going on that day. And then when it finally was detected again, it was through network analysis. And so don't discount this, right? This is the one thing. I mean, obviously there are ways to hide it and ways to try to conceal it, but this is it's going to make some noise, right? Like to do something, to execute an attack, it must send some traffic, right? So... network analysis is where it's at, folks, right? There's some things that are only very likely to be detected that way.
Right, and it's about layers of defense as well. So, there's breadcrumbs you're seeing over here, breadcrumbs you're seeing in New Relic through these types of capabilities. Hey, please, let's look into this further. On the right-hand side, application list and Modbus is an OT sample data here. DNS queries and what it's resolving into, and the production version we actually have host names is typically what our customers will be doing. Top talkers.
Yeah, I like that. Yeah, that's very useful.
Who's talking and so on. Again, this is purely based on network application. So you can obviously get top talkers relatively easily today, very easily today. But what this is doing is if there's a top talker that's a heart rate monitoring or baby monitor or something there to think about and look into.
Yeah.
HTTP response is actually one of our favorite use cases in TCP response time. So what happens here, Nika, is a lot of our customers, they draw a trend line that this is the TCP response time for an application. This is the HTTP response time. When somebody calls up and says, hey, my application is running slowly, they can instantly see that, hey, my TCP response time hasn't changed, but my HTTP has gone up. So that's kind of obviously points to an application related issue.
I hadn't really thought about that, but that actually is a super useful, like very like top level, just as you describe it, like what's a first thing to look at, Yeah. My classic is always just what's the throughput on each component, right? It's like before you worry about is the database throwing errors, like is the database getting requests, like question one. But yeah.
Right. I just realized I was on a 1 day or 1 hour time or 1 minute time or something. So the charts are a little bit prettier now, a little bit more data. I expanded to a 7-day window here. So, determining traffic, and this is the really, really important part. Nika, have you guys talked about the Tesla hack before? Like,
no. I don't think I've even read about it.
So this might be, it's actually been out for a little bit of time, and a lot of people are still afraid of it out there. So about 2.5 years ago, there was a company called Redlock Security, which is a sort of, they're out there looking around, and they found this this cryptocurrency mining running in Tesla's AWS environment. And long story short, adversaries came in. They found a Kubernetes console that was not configured as in no password. There was not a password put in. They went into the console, kind of used their tools to find other consoles as well, and they planted Monero mining software, cryptocurrency mining software, and it ran. People suspect this is still, the rest of this information is sort of bits and pieces coming out, for 8 months, and came out with under $1 million of cryptocurrency mining done. And 8 months later is when this Redlock Security came in. They found the problem, called up Tesla, and shut it down. So the reason this happens, and it goes back to your complexity point, Tesla is a fast-moving company, right? Yeah. They're installing apps and upgrading and changing their workloads all the time. For somebody to map that to the bill that they're getting, it's really, really hard to do.
Yeah, you're not going to know this just because you know your overall bill, right? Like that's just not, the billing changes or something. It's not going to even, there's enough happening that you're never going to tie it through to like, oh yeah, we deployed this one thing and that's why.
Right. So using the console, they used something called Wanamine, which is really Wanamine. It's a mining, it's a in fileless APT tool, basically based on Eternal Blue, which we in America invented NSA a while ago. That's been let loose in the wild. That's WannaCry is based on Eternal Blue as well. It's just painful for me to even talk about this. They use Flare to hide their IPs and so on. So I can get into details, but the point here is crypto mining is a thing because again, the route to cache is so much faster.
Yeah,
and just a couple more use cases, and then I'll kind of end.
So this is misuse. I mean, obviously we can see that, like, obviously what it's highlighting up is BitTorrent traffic, which often doesn't have a clear cache motivation, but is often just someone grabbing files that they should not be, and therefore maybe actually pulling something malicious, not intentionally. But then obviously the other big one here is like cryptocurrency mining, which can happen even for just internal actors, but yeah, very often is like an external hit, especially when you have, sadly, like infrastructure as code and like configurable infrastructure, like you open yourself up to that quite a bit more, which, I mean, it's good, right? It's good that it accelerates, but you really talk about there is this balance between accelerating your infrastructure and then being in a situation where nobody's telling you, hey, you can't set up 50 new virtual machines, in an hour.
That's exactly right. And again, the environment's changing, so it's hard to track. One way to track is to see what kind of network communications are going on. And that's really the moral of the story here. In this. And last point here is any kind of file extraction going on from your on-premises to wherever, file movement that's going on. So with that, Nika, there's a lot more I can get into, but I might take a pause. Happy to answer questions.
Yeah, let's see. We have a lot of viewers, which is great. Thanks everybody. We got a few dozen people watching on different platforms. So, hello Twitch, howdy YouTube. A gentle sort of acknowledging nod as we both walk to the coffee machine to LinkedIn Live viewers. Thanks for coming out. But yeah, I mean, this is the big piece. We have a link to the instant observability page. The quick start, I believe for Gigamon is like, it's 4 steps long. Like, it's not tough to do, folks. So I guess my one question is kind of for Gigamon as a general service, what kind of level are you saying, like, hey, it's time to start thinking about this? I mean, probably not the single developer in their garage or the contract developer who's configuring WordPress for clients, but do you see clients who are, the 4 and 5 person startup using Gigamon, or is it really for, sort of a level beyond that?
Yeah. So far, so there's value in a lot of different places, a lot of different organizations, and so on. The ones that tend to use Gigamon are large organizations where security compliance requirements, privacy requirements are a factor, and it's something that they're concerned about. So it tends to be, several thousand type of employees and up. So it's sort of the larger organization, definitely not the startup starting up in a garage. And the reason for that is when you're a startup, you've got really strong grip on the application, on its communications and so on. When you have 500 workloads, over 1,000 workloads, as a lot of our customers have, that's running, and the environment's always changing. And we always say the more complex the environment, the better value that you get out of having this level of visibility.
Yeah, one of the real benefits I see here is very clearly like the ability just to give people information about what is happening, probably intentionally in their architecture. And so for that, right, you're going to need 1,000 or whatever, hundreds of people on your team before, hopefully when you're a 20-person team, you pretty much understand what's going on your system, and nobody's launching massive big code changes without you knowing that it's even happening, right? So yeah, so that makes a lot of sense that would sort of be the point where people get interested. Yeah. So yeah, if people want to get try it out, do check out the instant observability pages. Do you have other tips for people getting started or sort of starting to explore this? I think a little bit about, you have the engineer or the management level who's saying, gosh, I think we might want to try some of these tools. This looks really appealing. Beyond taking a look and getting it set up, do you have other advice for them to sort of try it out in a small way before they're asking their CTO to go buy new services?
Yeah. So what this platform, this I really liked about this, it's not just the integration, but we have some sample data that they can play with and so on. They have a much wider set of attributes that they can play with as well, more than what I've shown here. So it's a sort of a built-in starter kit. If you wanted to see your own traffic in it, that's going to require installing our virtual product in the cloud, and for that you'd have to contact us, and we'd have to walk you. Actually, I take it back. You can download it from. We have test drives on AWS from our website. So just go to our website.
We have a great question from Rajesh on the LinkedIn stream, asking what percentage of overhead do these agents consume to capture these metrics? So I know that some of this stuff is agentless. Yeah, so we're using like a monitor who is making network, getting network information, and so that's not actually running an agent. But give us a sense for, New Relic has its own agents for application performance monitoring, but in your case, how do you answer these overhead questions?
Yeah, really good question. So this is something of highly sensitive topic for our customers. Hey,
sure,
another agent in, deploy it, manage it, and so on. So just before I talk about the load, deploying the agents works either using our UI that I showed you earlier, or you can just be tied into any kind of management infrastructure that you have that's native to the platform. So whatever you're used to using for orchestration, for automation, and so on, you plug into that. So there's two parts. There's the sort of the brain part of it, which is the VM that runs, and I don't know any figures, but the CPU usage obviously depends. It's a full application typically put into a VM. The one that Rajesh is probably really asking about is these taps. It's virtual taps. These are agents that run inside the VM. We have a container version of this as well, and so on. And typically this takes up, I believe, 6-ish%, depending on the volume of traffic coming in. Now, here's the difference. If you needed to extract that data and send that data to multiple tools anyway, whether or not Gigamon existed on the planet, you're going to be paying a price from an agent perspective. Because if it's just one tool that needs the traffic, then you can use VPC mirroring, which actually does have its own additional overhead it's adding. But then if you have two tools, that second tool is going to have to deploy its agent. For three tools that needs the traffic, third agent, fourth agent, and so on. What Gigamon does really well is that we can have multiple destinations with some level of filtering, so that data coming out of that VM or wherever that tap agent is running is already been sort of streamlined in the data that's sending out. So things like AWS VPC mirroring, it has one target, so you can have one destination, one tool, per HTTP. Let's say if 4 tools that need that HTTP data, there's the WAF, there's DLP, whatever.
And that Canvas system that we saw, and I don't know if you were on at that time, Rajesh, but being able to say, hey, I want this to go out to these multiple points, and I want to add some filtering before I do that. That's pretty powerful, right? Because we admit, right, like there are absolutely overheads with sending a bunch of observability data. So having the ability to say, hey, I want this to go out to multiple places, and I want to dedupe, or I want to do some other masking beforehand, that's kind of a killer feature.
Yeah, and also the second part of that question is just really around scaling up, scaling down. So there, when you go from 5 to 50 to 500 VMs, and then the application comes back down, we make sure that the visibility and the tools that have also been spun up to manage the traffic and so on scales down in a very, very efficient and quick way. So there's other cost benefits that we're providing that kind of makes up for that quite a bit. So things like if you have to egress any data out between regions, you have to take it out of AWS, let's say, you can bring it down significantly through filters, through deduplications, through metadata, which is a 1 or 2% of your entire packet type of data that you have to otherwise bring out. So there's a lot of other ways that Gigamon helps you save in the cost side.
Love that. All right, so we would love people to go and take a look at Gigamon Partners over on Twitter. I'll just drop the link in the chat. But Bassam, is there other ways people should follow you? As my favorite podcast asks, they say very seriously, where do you want to be found?
Thank you. I can be found. Would love to connect over anything. So it's at Bassam Khan, one word, BASSAM on Twitter. LinkedIn is where I spend a lot of my time as well. So just look up Bassam Khan on LinkedIn. And if you want to reach out directly, it's bassam.khan@Gigamon. And we would love to engage with you. So again, if there's one thing I can stress here, Nika, is that the stuff that we're building, we're pretty on the edge, not from a technology, whatever, but the use case and the application of network metadata that's been for security use case in particular, we're kind of scratching the surface with these 15, 20 different use cases, but there's a lot more potential. So we would love to work with people out there and start exploring more and more.
Yeah, I love that. Oh, fantastic. All right, so we're going to say goodbye to Bassam. Thank you so much for joining us. I'm going to take us to our Be Right Back feed.